Hello, and welcome to the Life Optimizer podcast. My name is Viktoriya. I'm a Yale trained midwife passionate about holistic health and wellness. And do I have something great in store for you today? Today, we're talking about the circadian rhythm and how this seemingly unimportant and automatic thing can really have profound effects on your mood, on your sleep, and on your health. We're going to discuss the science of the circadian rhythm. We'll also cover the science behind the adenosine pathway and how light affects our internal clocks. Okay. Whether you're a night owl or an early bird or just trying to optimize your schedule, understanding circadian rhythms can unlock major benefits in your health and in your productivity. Finally, we're going to discuss actionable steps to improve your circadian setup so that you have better mental clarity, more energy, all while decreasing risks for chronic disease. So, what is a circadian rhythm? A circadian rhythm refers to the natural internal processes that regulate our sleep, our energy, our hormones, and overall health. The circadian rhythm operates generally on a 24-hour cycle, more or less. It's more or less 24 hours. Circadian rhythm is not the same as a sleep wake cycle, while they are very much so connected, and the circadian rhythm affects the sleep wake cycle, which is the body's pattern or cycle that alternates between periods of sleep and wakefulness. Your sleep wake cycles are regulated by the circadian rhythm. So, body's circadian rhythm, what is it? It's the natural cycle of hormones, hormonal release, and everything else that happens as a result of that, things like melatonin, cortisol, that is regulated by light exposure and managed by the body's internal clock. So the body's internal clock or rhythm is set by something that's called the suprachiasmatic nucleus. This is a tiny cluster of about 20,000 neurons that live in your hypothalamus in the brain. So how does this work? Retinal cells, actually very specific retinal cells that are very, very sensitive to blue light, that live in the back of your eye, contain a photopigment called melanopsin, which is again sensitive to blue light. These cells, they detect light and send signals through the optic nerve to the suprachiasmatic nucleus in the hypothalamus. And what that does is it tells your body how much light is it exposed to. Okay. So interestingly, these signals that your body is sending from your eyes that detect this blue light, then that goes to the retinal cells that then travels through the optic nerve to the hypothalamus, or specifically to the suprachiasmatic nucleus. This is not part of our vision. We don't consciously do this. We don't consciously say, oh, there's a lot of blue light out here, I'm going to tell my body that to be awake. Our body doesn't consciously do this. What ends up happening is it bypasses the conscious part of our brain and goes to the suprachiasmatic nucleus, which then aligns the internal clock with the external day-night cycle, regulating processes like sleep-wake timing, hormone release, and body temperature. So, a study, a 2017 paper published in Nature Review Neuroscience, explained that the suprachiasmatic nucleus synchronizes peripheral clocks in the tissues like our liver, our heart, and our muscles to ensure proper functioning. So, those signals don't just tell us, oh, there's a lot of light outside, or there's not a lot of light outside. It actually goes all through our body to make us more in tune with the sleep wake cycle, to regulate when our hormones are released and when we feel sleepy, when we don't, etc. So, why does the circadian rhythm matter? When our circadian rhythms are aligned with natural light dark cycles, your body works more efficiently. You sleep well, you have consistent energy, and your metabolism and hormones are balanced. But when these rhythms are disrupted, what happens is you may experience poor sleep, mood swings, and increased risk of chronic diseases. And we're going to talk about why that is, why such a automatic thing that we don't even think about, how that can have profound effects on us, especially on people that tend to stay up late, especially on people that tend to do shift work or are shift workers. Okay. So circadian rhythm is tied to all of our bodily functions, and it's our internal clock that makes sure that everything is running smoothly and on time and is released on time. Okay. So that all of our organs can really run in sync with one another and the world, the day and night cycle. So another part of this picture, right, the sleep wake cycles, another part of this picture is the adenosine pathway. So how does the adenosine system fit in? So this is another piece of the circadian rhythm that helps us know when to go to sleep, or when we should go to sleep, I should say. So the adenosine pathway is a crucial mechanism that works hand in hand with the circadian rhythm to regulate sleep. And how does it do that? So what is adenosine anyway? So adenosine is a neurotransmitter that builds up in your brain throughout the day. It's a byproduct of our energy metabolism. Specifically, it's a byproduct from us metabolizing or using ATP. ATP is the energy molecule of the body, adenosine triphosphate, maybe you've heard of this. And so ATP, as it's broken down, creates adenosine. Okay. And so, as adenosine accumulates, it creates what scientists call sleep pressure. So, what is this sleep pressure? It makes you feel, that buildup of adenosine makes you feel progressively more and more tired as the day goes on. Okay. This acts like a homeostatic mechanism, because as the day goes on, you're using more and more ATP to do all the things, to run, to walk, to eat, to move your muscles, to think. So you're using ATP, and adenosine builds up through the day. And by the end of the day, your brain is full of adenosine, and your body's saying, "Oh, I'm really tired. I should be going to sleep." So there is something that can disrupt this, and that something is caffeine. So caffeine disrupts the system. What caffeine does, so the way that adenosine creates the sleep pressure is more and more adenosine uh, locks into the adenosine receptor, and so sets off a chain of events that make you feel sleepy as you need to rest. Caffeine doesn't allow that to happen. So what caffeine does is it blocks, or instead of adenosine attaching to that receptor, caffeine comes in and attaches to the adenosine receptor. So this doesn't stop adenosine from accumulating. So you're still using ATP, you're still producing adenosine, but you're not getting rid of it, and your body is not sensing that it's high to make you feel tired. So once the caffeine wears off, that caffeine pops off of the receptor, and all that adenosine in the midst starts to bind to the receptor. And have you ever had, a day when you're really tired already, you drink a bunch of coffee, and then by the end of the day, the caffeine wears off and you are dead. You are so tired, you can't function, right? So that's that adenosine, just the floodgates open, and it floods the receptors to say, you were exhausted, so you're even more tired. Often what we end up doing is, instead of taking a nap or going to bed early, is we have more coffee. And so it perpetuates the cycle. Now that caffeine goes back on the receptors, blocks the adenosine, so you're not feeling as tired. Other things happen as a result of caffeine. But then again, the coffee wears off and you're very, very tired again. Okay. So that's one part of the circadian rhythm that also plays a role. So, a study in neuropharmacology, a 2019 study, explored how adenosine signaling interacts with the circadian clock. And what researchers found is that disruptions in the adenosine pathway, whether it was through sleep deprivation, so you're not sleeping enough, that adenosine is building up over time. You go to bed late, you wake up really early, and so you kind of have high levels of adenosine. So your sleep deprivation can affect this too, or using a stimulant like caffeine. So both of those things, the study found, disrupts the adenosine pathway, which impairs the synchronization of the suprachiasmatic nucleus. The suprachiasmatic nucleus kind of can't synchronize with everything else in your body, just because the adenosine, the high levels of adenosine that are not being cleared out or are being blocked from working, are telling your body that you should be really, really sleepy, but the suprachiasmatic nucleus is seeing all the sunlight outside, and so it inhibits that synchronization that can happen. So while adenosine builds sleep pressure, it's the interplay with the circadian rhythm that determines the timing of when you feel mostly sleepy or most alert. Okay. So what other things besides the adenosine pathway can affect our circadian rhythm? And the biggest thing that can affect our circadian rhythm is light, our exposure to light. So light influences circadian rhythm, and light is the single most powerful environmental cue that regulates the timing of your internal clock. Okay, so in the sleep wake cycle, light exposure primarily triggers the release of cortisol in the morning. So you're exposed to light in the morning, your eyes see light, or even in your sleep, the sun starts to hit your face, you're exposed to light, and your body releases cortisol to make you feel awake. And then darkness stimulates the production of melatonin. Okay. That helps facilitate sleep. So essentially, light suppresses melatonin production and increases cortisol release. And light acts as a key signal to the body's internal clock to transition from being asleep to being awake and vice versa. So let's talk a little bit about light and cortisol. When light hits the eyes in the morning, the signal is sent to the suprachiasmatic nucleus, back to that same master clock in the brain, that then triggers the release of cortisol from your adrenal glands, that are little glands that live on top of your kidneys. Cortisol levels naturally rise in the morning, helping you feel awake and feel alert. And caffeine not only blocks adenosine, like we talked about, but it also stimulates even more cortisol release. So if you have caffeine in the morning, it stimulates even more cortisol release to help you feel even more alert. Okay, light and melatonin. Light and melatonin is a similar but opposite effect. So when darkness sets in, so when light is gone and darkness sets in, the suprachiasmatic nucleus signals to the pineal gland to produce melatonin. It says, it's dark outside, it's time for bed. And then that hormone, melatonin, is what induces sleepiness. Okay. And melatonin levels peak during the night and gradually decline as dawn approaches. Okay. So light impacts three big areas that then affect our circadian rhythms. So light impacts melatonin, secretion, okay, sleep propensity, and overall sleep quality. So three things. So how does light affect melatonin suppression and circadian disruption? Or melatonin release and circadian syncing up, I should say. So, how does light affect our circadian rhythm if we're exposed to it in the wrong time, when outside is light and we're in darkness, or vice versa, when outside is dark and we're surrounded by bright lights? How can that affect our circadian rhythm? So, exposure to light, especially in the evening, can significantly suppress melatonin production and not allow that melatonin to be produced and released. Studies have demonstrated that light can shift the timing of melatonin release, leading to that circadian misalignment that we talked about. So if you are at home, you have all your lights on, you have TVs on, you're on a screen before bed, your body thinks it's noon. It's not going to want to release melatonin. And so, because of that, it takes a longer time for you to fall asleep, and it disrupts when you fall asleep and how well you sleep. Okay. One study found that artificial light exposure in the evening has been shown to disrupt natural melatonin rhythm, which is linked to various health conditions, including sleep disorders and even certain cancers. That's a big deal. So this suppression of melatonin not only affects when you fall asleep, but also change the overall amplitude of the circadian rhythm, which can contribute to sleep disturbances and even mood disturbances. And the amplitude of that circadian rhythm is the amount of hormone that's released or blocked, right? So the peaks and the troughs of hormone. So you kind of, if you think about the amplitude, you wake up, you're groggy and sleepy, you never feel really fully alert in the morning, and then you're kind of sleepy through the day, and then you go to sleep, but you're not really able to fall asleep really well, right? You're exposed to light, so you're not able to fall asleep really well. You feel like you kind of go into sleep, but it's still not super deep sleep. So that's, you're not very alert in the day and you're not very sleepy in the night. So that's the peaks and troughs, that amplitude. So that light can disrupt that. Okay. So when bright light messes up the melatonin production, the body's natural highs and lows, are flattened. And a weaker rhythm can throw off the body's internal clock, making it harder to stay in sync with natural light and darkness. Okay. There is such a thing as chronotype and light sensitivity, and you might have noticed that in yourself. Okay. A chronotype is a person's natural preference for being active during certain times of day, like being a night owl or an early bird. Some folks, they're up at 4 a.m., and then some of us are up at, 12, 1 o'clock. So really be in the morning, I should say. So really being aware of where you fall in terms of chronotype and your natural tendencies also will help you sync your body up with the outside, light and dark cycles of the day. Research shows that people with a later chronotype are more sensitive to evening light, okay, which can further delay their circadian rhythm. And I am one of those people. If I'm exposed to a lot of light in the evening, I have a harder time going to sleep. Okay. And when I do go to sleep, I need my room, my bedroom to be completely dark. Even a little bit of light disrupts my ability to fall asleep and achieve deep sleep. And so that really pushes me to be a night owl, because if I'm still working on things, if I'm on a screen, if I'm, writing, etc., and I'm exposed to a lot of light, when I'm done with that, my body still thinks that it's noon and I should just be up and going a lot. I'm very, very sensitive to that evening light. So what does that mean? This connection just shows us that we need to customize what we do for each one of us, paying attention to, are we sensitive to light? Are we not? How is our sleep when we sleep in a bright room? If you fall asleep on the couch with the lights on and you wake up in the morning, do you feel like you never slept? That might mean, well, that most people will feel an effect of that, but that might mean that you're very sensitive to light. Okay. And so paying attention to even the chronotype and your sensitivity to light. What about light wavelengths? So when we talked earlier about the suprachiasmatic nucleus, what I said is that it's very, very sensitive to blue light. So shorter wavelength light versus red light. So sensitive to blue light. The wavelength of light is also crucial in determining its effects on circadian rhythm for that reason. Okay. And so we know that blue light is more effective at suppressing melatonin. So that bright light suppresses melatonin, shifting the circadian rhythm as compared to longer light like red light. And so exposure to blue light during the day can really help you feel alert and improve your cognitive performance. But exposure in the evening can lead to difficulties falling asleep. Okay. So this again highlights how important it is to manage light exposure throughout the day to align with our natural circadian rhythm and the type of light that we're exposed to. And we're going to talk about how to do that in just a minute. So we can change our environmental light conditions, right? How do we expose ourselves to the right light at the right time? So we can change our environment. So what does that mean? Having good lighting throughout the day, right, can significantly improve sleep quality. So studies show that exposure to bright light during the day improves sleep quality at night by reinforcing the circadian rhythm. So when it's sunny outside and it's sunny or bright in your house, your body is in sync with that. So things like if you are spending all day in a dark bedroom, on screens on a computer working, or playing video games, your body thinks it's nighttime, so it's not making those same hormones, it's not syncing up with what it looks like outside and the circadian or the night day cycle outside. Okay. Inadequate light exposure during the day has been found to lead to circadian rhythm misalignment and poor sleep quality, especially in populations like night shift workers or those with irregular schedules. Wherever you are, you want the light that you're being exposed to really align with what it looks like outside. So If it's daytime outside, you have lights on in the house. If it's nighttime, you're dimming down lights, things like that. And we all know that technology impacts this. So the rise of electronic devices emitting blue light has really raised concerns about the effects on sleep quality. And research shows that the use of screens before bedtime can delay sleep onset and reduce sleep quality due to that suppression of melatonin that we talked about from the screens. And so a lot of times the studies have recommended that we reduce screen time in the evening and use blue light filters, blockers, etc. And even I would go to say to churn your screens to have red light filters so that red light is being emitted instead of blue light. Sometimes those blue light filters are not enough. And we're going to talk more about that and more about exactly what to do in just a second. So, to review, light significantly influences circadian rhythm through the mechanisms that we talked about, that melatonin suppression, individual sensitivity based on your chronotype, right? All those things. And managing that light exposure, especially in the evening, is essential to maintaining a healthy circadian rhythm and improving sleep quality. I have some really good strategies for you next to talk about how to improve your circadian rhythm. Now that we know all this, let's talk about actionable tips to help improve your circadian rhythm and really help your body align. Okay. So, one thing is morning sunlight exposure. Morning sunlight exposure helps reset your circadian clock and boost serotonin, which serotonin is later converted to melatonin, that sleep hormone that I talked about. So, one, light exposure in the morning boosts serotonin. Why do we care about serotonin? Well, serotonin is a neurotransmitter that affects your mood, your sleep, digestion, wound healing, bone health, blood clotting, and sexual desire. So we care about serotonin a lot, right? It is connected to a lot of things. And like I said, morning light exposure helps reset it and helps boost serotonin. So how does that happen? Exposure to natural light in the morning sends signals to that suprachiasmatic nucleus that's located in the hypothalamus, which regulates your circadian rhythm. That's what we talked about. And consequently, the synthesis and release of neurotransmitters are also regulated by the hypothalamus, and so causes an increase in serotonin release. When bright light enters that eye, it stimulates that suprachiasmatic nucleus, and serotonin is produced as a result, which then again in the evening it is converted and released to melatonin. So ideally, research shows that we should be spending 20 to 30 minutes outside within an hour of waking up, and ideally without sunglasses and not through a window. So if you are thinking, well, I sit and have my breakfast or I work by a window blocks light by 50 times. And so for you to get what you need by sitting by a window, you'll be sitting there until tomorrow and you still won't get that stimulation to your suprachiasmatic nucleus. So going outside for 20 to 30 minutes, and you're going to think, well, that's a lot of time. I don't have 20 to 30 minutes to do this. Totally fair. I would say start with 2 to 5 minutes. Start with 2 to 5 minutes. I would even push you to say, you brush your teeth for 2 minutes, go outside and brush your teeth for those 2 minutes if you really can't find an additional 2 minutes. And if you're a person that hasn't done this, that is always inside or their job is inside, which is essentially most of us, you're going to see that you're already going to start to see a difference because your body is, going to be so excited to be synced up and your circadian rhythm to be more in sync with the outside world. Okay. So again, ideally 20 to 30 minutes within an hour of waking up. And even on a cloudy day, that's still fine. All you have to do is, again, allow your retinas to see those sun rays. So that morning light is going to be amazing for you and for syncing up your circadian rhythm. You're waking up and you're saying, hey, I'm awake. Here's the sun. Here we are. Like here goes the day. What else can we do? The next thing is limit blue light at night. I think you knew that this was coming. So blue light suppresses melatonin, and that's going to delay sleep onset. So use either blue light blocking glasses in the evening, change your screens to have a red color filter. All screens can do this, and you can set it where it's a click of a button and your screens go red. On your laptops, on your iPads and other devices, TVs, things like that. Enabling night mode might not be enough of a block of the blue light. And so, again, doing something like the glasses or changing your screens to even, like I said, the red color filter. And really avoiding screens 1 to 2 hours before bed is key. That's what the research says. 1 to 2 hours before bed, not having screens on. Okay. What else? Maintaining a consistent schedule. So, why? Research shows that irregular sleep wake times confuse your internal clock. So if you're waking up at 5 a.m. one day, at 10 a.m. the next day, and then, on a Saturday, you're sleeping in till noon, your body doesn't know which way is which. It's not super fast at adjusting when to release hormones. I mean, these are huge, complicated processes that are happening in our body. And so it's used to releasing hormones one way on one day, another way on another, and it doesn't really know which way to go. And so you want to maintain a consistent sleep wake cycle or sleep wake times, even on weekends, okay? Which means going to bed and waking up at the same time every day, again, even on weekends. What else? Another thing that you can do is control your evening lighting. So, not just screens, but lighting in general. So, dim lights signal to your body that the sun is setting, it's time to wind down, it's time to sleep. So, use warm, dim lights in the evening. You don't want to be under fluorescent lights. Of course, us shift workers, we are under fluorescent lights at night. But if you can help it, if you're not a shift worker, then you're using dim lights in your house and avoiding bright overhead lights after sunset. You want the inside of your house to really try to mimic. And I know some folks will even put a red light bulb in their bedroom to really simulate that setting sun wavelength. Okay. What else can you do? Exercising daily. And no, I don't need you to start a brand new exercise routine. Everything's fine. But we know that physical activity strengthens the circadian rhythm and promotes deeper sleep. And so, really, it's 30 minutes of moderate exercise, except you're not doing exercise before bed because that's very stimulating. And what's going to happen is you're going to be stimulated and not fall asleep well. So, not before bed, no vigorous workouts close to bedtime. But 30 minutes, so 30 minutes of walking on your lunch break, something like that, right? Nothing crazy. Or maybe when you wake up in the morning, you plan to go outside and walk for 30 minutes. You get your exercise and you get your morning light all at the same time. Something to think about, which I know that it requires planning and all the other things. But you could do a two-part. You get your sunlight, you get your exercise, and you're going to sleep better that night. Okay, what else? You can also align your meals with the day. There's a whole new area of research right now, which is called chrononutrition. And what they're finding is that how we eat, when we eat, and what we eat really affects our circadian rhythm more than we ever thought. Okay, so chrononutrition is the study of how the timing of food intake affects our health, and in particular, how the timing of food intake affects our metabolic health and chronic diseases. And what they are finding is that the timing of our food intake affects things like cardiovascular disease, obesity, and diabetes. And you might say, well, I'm not obese, I don't have cardiovascular disease, and I don't have diabetes. You're right, you probably don't. But what we know is the timing of food intake affects your insulin sensitivity and the ability for your body to regulate your blood glucose, how sensitive your body is to how insulin works, and how quickly your body removes glucose from your blood, and how it is able to balance your blood sugar. So really important. So if not regulated over time will lead to diabetes. It affects weight gain. So maybe obesity is not something that you're dealing with now, but it can affect weight gain, and it can affect cardiovascular disease, which again, cardiovascular health, I should say, which is your heart health, which over time can lead to cardiovascular disease if we don't pay attention to it. Okay. So what does all that mean? What that means is having regular meals. regular meals and eating at a regular time every day is key. It also plays into telling our body when your body should be awake or when it should be asleep. Okay. Breakfast plays a huge role in this. And so skipping breakfast is not the thing to do. You want to eat a substantial breakfast, preferably high in protein, at least 30 grams of protein in that breakfast. Again, to really tell your body, I'm awake, I'm ready to digest food, here's nutrition. So skipping breakfast is one thing that you want to avoid if at all possible. Eating regular meals is the other one, not skipping meals. And then eat your largest meal earlier in the day and avoid heavy meals within 2 to 3 hours of bedtime. But really, the evidence suggests that stopping eating about 2 to 3 hours before bed is advisable to promote better sleep quality and metabolic health. It allows the time for your gut to start to move the food, and then allows the time for your body to quote unquote clean everything else instead of spending time digesting the food all night. Does that make sense? So it kind of gives your body a little bit of a break. Okay, what else? Last but not least, manage your caffeine and alcohol. So what does that mean? Preferably no alcohol, but if you are drinking alcohol, you're avoiding alcohol 3 to 4 hours before bed because it can disrupt sleep quality and timing. And then really you are keeping caffeine in the morning hours. Caffeine has a 10 to 14-hour half-life, so it takes a long time for your body to clear that caffeine. And depending if you're very, very sensitive to it or less sensitive, it'll vary, but it does take a long time for your body to clear it out. So if you're having it late, your body's not, that adenosine pathway is being affected. Okay. So today we reviewed circadian rhythms. We explored the science of your body's internal clock, the adenosine pathways that can regulate that sleep pressure, and how light shapes your sleep and wake cycle. And most importantly, we shared actionable strategies to optimize your circadian rhythm. For this week's Optimizer Challenge, I'm going to just offer up that you try one of these things that we talked about. One thing that we talked about to see if you can really help your body sync up the circadian rhythm. And keep in mind that light is the biggest factor in your circadian rhythm. So you can start there, changing your light exposure, because that's the biggest factor that affects your circadian rhythm. Remember, tiny changes lead to a whole new you, so start optimizing today. Thank you so much for being here and for listening. I appreciate your time. Subscribe, share if this is something that would be helpful to somebody you know. Definitely share, rate this episode, and let me know how things are going and if anything that we've talked about today has really stood out as something beneficial for you. Thanks again, and I'll see you next week.